Nowadays, it is critical to lead effective performance of your work through all the phases of your project, and technology is available to achieve it. In this video, we are going to show the workflow between Advanced Design, Revit and Advanced Steel. In particular, we are going to create a model in Advanced Design and then export it to Revit, where we are going to check and make some changes, and then coming back to Advanced Design and synchronize the model, updating all the information. Once we have done this, we will run again the model in Advanced Design, and we will export all the information to Advanced Steel, where we are going to design some of the connection. Done this, we want to update our model in Revit, as it is our lead software, to then create the final drawings. One of the aspects of Advanced Design is that modeling is really visual and recall a lot of shortcuts and features. We create our columns, which characteristic can be found in the Properties menu. We can copy using the Copy tool, or holding the Control button will allow us to copy our element by dragging them. When we use the cut function, the preview helps us to understand if we are working correctly. We set different subsystems in our project to help us to select and amend elements and to analyze the results. To help us to draw our structure, we can also use non-structural elements such as points, lines, grids, and load areas. Load areas are non-structural entities that spread the loads between the elements we define them. The main features are that we can choose the span direction, we can create rigid diaphragm, and we can give the self-weight of the slab. If you want to mesh the slab with the structure, we can still create plate elements that will be meshed with the structure and will give the stiffness required. The model will be completed by bracing and support, and then copied in different levels. Once we have built our structure, we are going to place the loads. To do that, we just select our load areas, and with the right click, we can have access to the quick menu that allows us to insert loads on the elements selected. We create, in this case, dead loads, live loads, and wind loads. Loads are as well entities. To copy them, we can also hold Ctrl and drag them. To make changes is quite easy. We select the load and make the amendment required. On the top of the building, we are going to put a different kind of load. Wind loads can be automatically generated. In this case, as it is only a sample, we are going to place some point loads, just to show different combinations. You can set as many combinations as you want, and divided them for the different verification for steel, timber and concrete. You can also use the simplified combination that will generate automatically combination for the code chosen. Now our structure is complete. We verify that everything is fine, and then we can run the model. Once the model is analyzed, we have a look to the forces and moments in the structure. Then we export the model to Revit. Once imported, we can see that section, orientation and eccentricities of the elements and the loads match the one drawn. We open the analytical model and we check that the analysis imported gives us the same results of Advanced Design. We choose the moments and we select the right combination. We make some changes then to our structure. We make some change in the front columns, which section will be increased, while the section of the roof beam will be smaller. We then export the model with the changes, and we are going to synchronize the model in Advanced Design. The changes of the section are shown in blue. First, we are going to synchronize the beams of the roof and then the columns. We accept the changes made and then we apply them to the structure. Now our model is updated and we can run the analysis again. We have a quick look that our results have been updated, and then we export the model again. We export in SMLX file for Advanced Steel and in GTCX file for Revit, where we will update the result of the analysis. So we can go to Advanced Steel to create our connection. We import the model, and as you can see, the forces have been imported in the nodes and splits as well. We create initially our splice plates. We assess the connection volt and we choose the connection we want to insert. To check the connection, we can select to use the forces brought from Advanced Design. We have a look to the report, where we can see that the forces has been correctly imported. To check the forces in Advanced Design, we select our member and open the detailed diagram, where we look at the forces in the node in which we accept the connection. Finally, we create the base plates and we copy them in all the columns. Advanced Steel Connection Volt creates automatically the connection with the parameters indicated in the green book. Now our model has also the connection inserted. To export them, we first need to number them. Then we can export them to Revit, where we will have the model complete. In Revit, we go to the Advanced Steel Extension tool, where we synchronize the model. We filter the connection and we apply the changes. We can see that the connection in Revit have full intelligence and can be amended and modified as we wish. Now the workflow is complete. We have the full data shared between the software and we can create reports and drawings.